Okay, so today we're going to talk about the scientific method. Scientific method is something that you can use for everyday problem, something that you will use in every science class that you have for eternity. If you ever have a question that you need answered, use a scientific method. It's very possible. You can even do it if you can even use this in like relationships that you have. So, does my best friend hate me? Then you can go through and use a scientific method to figure out if your best friend actually hates you or not. If you want to, we can watch this video. Uh, we'll watch it another time. It is just a Big Bang Theory showing how they use scientific method. So basically, what we have is we have a process of figuring out a question, making observations about that question. We will then formulate a hypothesis, test that hypothesis, gather data based on that hypothesis, and we'll either refine it, test again, or we figure out if our hypothesis is incorrect or not, and it basically explains that in a conclusion. That's as simple as you can get. So there are 6 common parts. Like I said, you can add any steps, you can repeat any, and you can skip steps altogether depending on what your question is. So the pattern of investigation of procedures is called the scientific method. So here is the 6 basics that we talk about. State the problem, research and gather information on that problem, because if there is a problem like what are the 7 continents of the earth, you can actually go over and research about that question and find answers to it without even having to form a hypothesis, test hypothesis, analyze data, draw conclusions. Research and gathering information is what every scientist, what every person who asks a question should ask first. Once you find that problem, you research the problem. So, for instance, is my boyfriend or girlfriend cheating on me? You research. You can look through their phone. You can ask them questions about where they've been. You can ask their best friends questions about where they've been. That is research and gathering information. That is a problem. I think so. In once we've gathered that information, you've gathered information saying that, oh well, your girlfriend or your boyfriend told you that they were at their parents' house Saturday, but really their best friend said, oh, they were at my house. So there's some information that might make you form a hypothesis along the lines of, I think my boyfriend or girlfriend is cheating on me. So then you go through, test that hypothesis, analyze the data based on that hypothesis, and you get to draw your own conclusion. Now, that being said, it's not always true, and your hypothesis is not always true, but you are testing out that hypothesis. So, many investigations begin with someone observes an event. So, if my girlfriend looks like she's getting a little too friendly around other guys, then that seems different to me. Or there's text messages that she won't let me read, or things like that. Scientists often pose the question about that. So in specific scientific rules, why do objects fall towards the Earth instead of floating or staying away? Why does it take significant propulsion by planes or rockets or helicopters to be able to not fall towards the Earth? Or what causes day and night cycles? How do we generate electricity? These are all scientific questions, but like I said, you can use it for your own personal life as well. So research beginning, you research the problem that you see. So has anybody else done research on this? Has anybody else tested this hypothesis or this problem? Has anybody else written something about this problem? If you don't have this background information, you will have too general of a hypothesis. So, for instance, in the girlfriend-boyfriend scenario, if you only see that one instance, you don't have enough information to actually form a reliable hypothesis. Now, if you go back and you do the research, you can form a reliable hypothesis. So a hypothesis is a possible explanation for the problem. So for instance, when you look at that video, you can look at the hypothesis of the Big Bang Theory clip, but we're going to talk about something more prevalent. So why do things follow the Earth? After I've done my research, it seems like everything, given enough time, will follow the Earth. Even birds. If birds do not fly, they follow the Earth. So in my hypothesis, I believe that there is some sort of force from the Earth that is causing things to fall towards it. And that would be my hypothesis. Or you could say, I believe my boyfriend or girlfriend is cheating on me because the actions they have taken lately, things like that. So hypotheses are tested by making observations. So for instance, you can make observations about your question and you can build information gathering on that, gather all of your information to be able from your test. You can build a model. So for instance, if I'm building a model of the Earth, I can figure out how a object falls to the Earth. Same thing with day and night cycle. Or you can conduct an experiment. So I can put these two substances together to see if there's any sort of reaction. Or I can feed I want to see what kind of dog food my dog likes, so I will feed him in different cycles, different types of food. Experiments like that. Also for the gravity thing, just a little background. In 6th grade, I did a parachute project, and it was one of the funnest test to hypothesis I've ever done, just to let you know. But anyways, so testing your hypothesis. This comes down with an experiment. When we test from an experiment, you have to make sure that you have a control and a constant, so a dependent and independent variable. So your dependent variable changes according to the changes of the independent variable. So think about this. When you're dependent, you're dependent on something. Independent, that means you're by yourself. So the independent variable that is changed to test the effect on the dependent variable. So that being said, you have a constant that does not change when all the other factors change, because you want to make sure that you have something to test against. So for instance, with my dog food, I'm going to feed my dog dry dog food on Monday, Tuesday, Wednesday, no matter what, at lunchtime. But I will feed him wet dog food or scraps other meals during the other times. So I'll change that variable. We'll see if he continues to like that dry dog food or not. So the control is the standard at which the test is being compared. So that makes sense. So we'll look at Becky's situation. So Becky wants to figure out what type of liquid works best for growing beans. She watered one with Coca-Cola, one with lemonade, and one without adding anything, and one with just water. After 1 week, she measured how high they had grown. So the independent variable is our liquid added. So we're changing that. The dependent variable is the plant growth. So we're wanting to know how it grows the best, but we're changing the liquid added. So they are dependent on which liquid is added. The control is the plant without any liquid because we're doing nothing to it. So that means it is staying the same. And our constants are the environment, liquid, and the amount of liquid, the soil and the beans. They're all going to be the same type. So that way there is nothing different between each thing that can cause a change. So because you don't want a different type of bean that's going to grow faster or slower, no matter what you do to it. All right. So Angelique wanted to find out what shampoo made her hair the shiniest. Every day she washed her hair with different shampoos and then rated how shiny her hair was. So on a scale of 1 to 10, she used Pantene, Herbal Essence, L'Oreal, and Just Water. So our independent variable is the type of shampoo she uses. Our dependent variable is the scale of 1 to 10. So that is how she is seeing it. Control variable is just water, and then our amount of shampoo, temperature, and time are always the same. Make sense? All right, so when observing something too big or something too small or something that is completely hazardous, we create a model. A model represents an idea, object, to help people understand it. So, for instance, if we're talking about the universe, that is something way too big to talk about that we can actually do. And then if we talk about a cell or an atom, it's way too small to be able to test with. Or if we're talking about very hazardous materials, so if we're talking about, I don't know, figuring out which gasoline burns the purest, that's something that we may want to do with a model instead of a full-scale burn. So once we've done our experiment, we analyze our data. An important part of every investigation includes recording down what you see. If you don't record what you see, you are not doing it the correct way. These are easy to read in tables and graphs. In science, we use line graphs because line graphs are the most reliable for science purposes. If the data are not organized in a logical manner, wrong conclusions can be drawn. So, just like baking or cooking, you have to add ingredients in a specific order and cook for a certain amount of time, or else it is going to do things the wrong way. That's why a great cook can be a bad baker, but a bad baker can't necessarily be a terrible cook. You know what I mean? Because being a cook, you can cook things a little bit different every time and kind of get the same result, but baking is not the same. If you do not do it the same way, you will not get the same results. And especially this last part. This is extremely important. Scientists share their data with other scientists. You share your data with your peers and with your teacher. If it is not organized, I cannot give you a grade for it. Your partners won't understand what you're talking about, and you will have gotten nothing from your entire experiment that you created. So data being organized is extremely important. So final step, draw a conclusion. We decide whether a hypothesis was supported or not. If it was not supported, you could have gotten your answer. A lot of the time, hypotheses don't need to be, but are yes or no questions or answers to questions. So either you're right or you're wrong, and that can give you an answer. But that being said, it doesn't always work that way. Sometimes you have to go back, so critical thinking is very important. You have to identify the problems with your hypothesis, with your experiment, and you go back and try again. You can, if it is completely incorrect, you may have to try again or do a completely new hypothesis based on what you know and test that hypothesis. Remember, in order for something to be true, it must be repeatable. That means when you analyze your conclusion, your conclusion needs to be repeatable through other experiments. So, for a hypothesis to be considered valid, the experience must be the same data every time. So, like I said, data does not support the hypothesis, it must be revisited, and the experiment's procedure needs to be refined. And that's the scientific method. I'm sure you have gone over the scientific method in every single science course that you've had in your life, but it is something that needs to be constantly reminded, or else you may not completely get what you want from it. So if you skip steps, or if you don't think are needed but are actually needed, if you don't put your data right, the most important thing that I can teach you once you start high school is make sure when you test your hypothesis, you organize your data to where it is properly used. All right. So that's it for today. Hope you got done with your notes. We will have something that kind of helps us get through this. And good luck. Have a good day.